Hi everybody, Matt here with the third video of Let's Code a Networking Stack. In this video, we're going to look at writing a protocol manager, and this is a small subsystem that is going to be responsible for moving packets around in the protocol stack, as well as keeping track of which protocols have been registered in the system. So let's begin with a quick refresher. We had our protocol stack as before, and also a packet object. This object needs to move both up and down the protocol stack, passing through each protocol so that it can be processed. And that is essentially the job of the protocol manager that we're going to look to code. So let's take a closer look at a single protocol. We'll now introduce two new functions that each protocol must implement, TX and RX, short for transmit and receive. Let's bring our packet back, but this time we can see there is a dir property shown. This represents the dir enumerator that we added to the packet structure in the last video. In this instance, its value is tx, and as such the packet would be passed to the tx function of this protocol. If the dir was rx, it would call the rx function instead. And this is how the protocol manager is going to direct packets to either the receive or the transmit path of a particular protocol. So let's take a look at how all this is going to work in practice. We have a protocol here and the network card with the tx and rx functions showing. Let's now register a new protocol, protocol B, and add it to the list. We maintain a list of registered protocols that packets can be passed to. The next structure that the protocol manager maintains is a queue of packets that need processing through the networking stack. Let's pick out the first packet that is at the head of this queue. We'll now add another member to the packet structure called a handler. This member tells the protocol manager which protocol this packet should be passed to next. This, along with the dir member, allows us to choose the exact function that the packet object should be passed to for processing. Let's now add that member to all the elements of our packet queue. The packet that we're currently processing will be passed to the tx function of protocol A, as can be seen via the members. Once there, protocol A will process the packet and set the handler to the next protocol that the packet should visit. Let's say protocol B. The packet is then returned to us, at which point we inspect the dir and handler members to determine the appropriate function that the packet should be passed to next. Protocol B will then update the handler method and set it to the appropriate protocol to be called. When the packet is passed to the network card, all the data is gathered and transmitted. At this point, the packet is no longer needed, and we set the handler to a special value that we call drop. When the protocol stack processes a packet whose handler is drop, it simply destroys that particular packet and all associated buffers. Let's now pick a packet off the head of the queue. This time it is an RX packet, and pass it to the appropriate function. As before, this function will modify the handler to tell the protocol manager which RX function the packet should be passed to next. Once returned, we then pass it to protocol A's RX function. At this point, there are no more protocols left for the packet to visit. Any user data that the packet has is passed to the user, and the packet handler is set to drop. Once the packet is passed back to us, as before, we destroy the packet. So that is a high-level overview of how the protocol manager works. In the next video, we'll write the code for this subsystem, which will then allow us to move packets around the protocol stack. Thanks for watching.